We're continuing with the AB36 review. Calculators are not allowed. This is number 4. On all 3 of them, we are asking for the slope of the tangent line to the following curves at the specified points. So what that means is we've got to find dy dx, or the derivative, which is going to be the slope, and then evaluate that derivative at each of these points. So for part A, in order to find dy dx, I have those 4 steps that we learned in section 3.6 skill 1, which is we will take the derivative of both sides with respect to x. And then as I run this derivative through the left side, I encounter a product rule, which means I'll have the first one times the derivative of the second, plus the second times the derivative of the first. Then I move through the subtraction, through the constant, hit the y. The derivative of y with respect to x is dy dx. Move through addition, move through the constant coefficient, then hit the power, so that's 2y to the 1 power times the derivative of the inside, which is y, with respect to x, gives me a dy dx. On the other side, the derivative of a constant is simply 0. So that's step 1. Step 2 is to now collect the terms that have dy dx's in them together, and the things that don't have dy dx's in them go on the other side. So we can see that we have 3 terms with dy dx's and 1 without. So this y will move over to the left, or excuse me, to the right, and we'll leave these 3 over here and do step 3 at the same time, which is isolate, or factor out, excuse me, the dy dx. If I factor dy dx out of this term, there's a 1 times an x. If I factor it out of here, I get a 2, and if I factor it out of here, I get an 8y. So now isolating dy dx, I will have a negative y over an x minus a 2 plus an 8y. My goal is to now evaluate at 4, 1. So that means everywhere I've got a y, I need to put a 1, and everywhere I have an x, I put a 4. Finish it up, I get a negative 1 over a 2 plus an 8 is a 10. Now let's look at B. B, same process. I'll come up here. I'm going to differentiate with respect to x both sides. So on the left, notice I again am going to have to apply the product rule. So I'll have the first one times the derivative of that y with respect to x, plus the second one, which is y, times the derivative of x squared with respect to x. Then I move through the addition, hit this term, and I'll do the power first, leave the inside alone, and then multiply by the derivative of what was raised to that power. Hit the constant, move through this. Again, it's a constant, so derivatives are 0. Now I have 2 terms involving dy dx, so they will remain on the left, and this one will move to the right. So I'm going to kind of combine step 2 and 3 together. I'll move that to the other side, make it negative, and then I'll factor out the dy dx out of what remains. So that's an x squared plus a 2y. So now if I isolate dy dx, on top I have a negative 2xy, on the bottom I have an x squared plus a 2y. My goal is to evaluate that slope at 2, negative 2. So I plug this in. Everywhere I have an x, I plug in a 2. Everywhere I have a y, I plug in a negative 2. Notice I get a 0 on the bottom, so that means my slope does not exist. I'm going to have a vertical tangent line at the point 2, negative 2. Last one, part C. Again, I'll differentiate with respect to x on both sides. And here's one of the places that people will mess up, and that is they will neglect to carry the negative with the 2. when they're creating a product rule out of this. So first one, that's an easy one to take the derivative of. We get a 6x. Now we need to take the derivative of a negative 2x times a y. So that's a product rule. So we'll have the first one times the derivative of the second plus the second times the derivative of that negative 2x is a negative 2. Notice that since the original term was negative, both the product terms, derivatives, are going to be negative as well. Then we move to the y squared, derivative of that, move the power down, then multiply by the derivative of the inside. And on the right, we'll get derivative of a constant is 0. Again, we need to collect the things that have dy dx's together, and the things that don't, we move to the other side. So on the other side, I'll have a positive 2y and a negative 6x, and on this side, I'll factor out the dy dx, which will give me a negative 2x plus a 2y. Isolate dy dx by dividing by this, and then evaluate at the point 1, negative 2. Everywhere there's a y, I'll put a negative 2. Everywhere there's an x, I'll put a 1. End up with negative 10 over negative 6, which reduces to positive 5/3.